Hello students, welcome to our Math Genesis. In these online sessions, I will be discussing on the class 8 maths basically from NCERT syllabus. Okay, in today's session, we'll start with the chapter 1, that is rational numbers. Okay, before we go deep into the rational numbers, we'll discuss some of the concepts which we already knew them. Okay, it starts with the natural numbers. What are natural numbers? We all know that counting numbers are called as what? Natural numbers. Yes, counting numbers are natural numbers. And they start from what? 1, 1, 2, 3 and so on together. Up to infinity are called as the natural numbers. Alright. Then comes the whole numbers. What are whole numbers? If to the natural numbers, if you add 0, okay, then those numbers are called as the whole numbers. So it starts from 0, 1, 2, 3 and so on up to infinity. Alright. Then comes the concept of integers. What are integers? Integers are nothing but which are having the negative numbers as well as the positive numbers together are called as the integers. So what are integers? So it will be starting from some infinity, -2, -1, 0, 1, 2 and so on. That's the concept of integers. Next comes the concept of fraction numbers. What are fraction numbers? Fraction numbers will have a numerator as well as the denominator. So it will be in the form of a by b. Alright. So this is the numerator and this is the denominator. Okay. Where a comma b are natural numbers. So fractions are in the form of a by b, where a and b are natural numbers. Here it's nothing but a value and b value will be natural numbers. What are natural numbers? Numbers starting from 1. Alright. Next comes the rational numbers. Okay. Rational numbers are those numbers which are in the form of what? P by Q. Okay. Where P comma Q are integers. Alright, what are integers? Integers means what? Both negative numbers as well as the positive numbers. So over here you can have negative numbers as well as the positive numbers. And Q is not equals to 0, which means the value of the Q should not be equals to 0. Okay, this is about the rational numbers. Okay, this is the basic introduction of the rational numbers. Okay, now we will check about some of the properties of the rational numbers. Alright, now we'll discuss the properties of the rational numbers. Okay, first one is the closure property. Okay, suppose you take two rational numbers. Example a by b, comma c by d. So in closure property we have to check for all these 4 operations. So we'll start with addition. Okay, whether in addition this closure property will undergo this addition or not, we have to check. Okay, now what are these two? These two are rational numbers. Okay, in terms of addition, if the two rational numbers, the sum of these two rational numbers should be also a rational number. Okay, example 2 by 3, 4 by 5. Alright, I have taken the two rational numbers. Okay, now what is the closure property? Sum of these two rational numbers should be also a rational numbers. Okay, so now we have to going to apply addition. 2 by 3 plus 4 by 5. Alright, now if you take what? LCM 15. Okay, 3 5s are 15, so 2 into 5 plus 4 into 3, which is nothing but 10 plus 12 by 15. Okay, which is 22 by 15. Okay, which is also a rational number. So what does the closure property says in terms of addition? With any two rational numbers, the sum of two rational numbers should be also a rational number. Now this is done, right? So in terms of addition, it is true. Okay. Next we'll check in terms of subtraction whether it's true or not. Okay. Now the same condition, I'm taking the same numbers. Alright. I'm just subtracting it. Okay, so here also it's being subtracted. Okay, now I want to keep here in a bracket because the sign is there. Okay, now 2 5s are 10 minus 12. Alright, now 10 minus 12 is minus 2. So minus 2 by 5, is it a rational number or not? Yes, it's a rational number. So closure property in terms of subtraction is also a rational number. So this is also true. Now we'll check with multiplication. Okay, this time let me check some different numbers. Alright. Okay, for example, I'll take minus 1 by 2, 4 by 7. Okay, I'll check the multiplication of these two numbers. Alright, so minus 1 by 2 into 4 by 7. It is just simple multiplication. Minus 1 into 4 is minus 4 by minus 2 into 7 is 14. So we can still reduce it to the simplest form, which is nothing but 2 2s are 2 7s are. So it is minus 2 by 7, which is also a rational number. Alright, so in terms of multiplication also, it's a rational number. So it is also done. Now we'll check with division. Alright, so I'll take the other numbers like 2 by 7, minus 11 by 40. Okay, I'll check whether this will go in terms of division. Okay, so what implies 2 by 7 divided by minus 11 by 40. Okay, when division sign is there, how we will be solving? With this division sign, we will change the sign to multiplication, and to this number we will write in the reverse of that number. Okay, so it comes 2 by 7 into 40 by minus 11. So like this only we will be solving, right? When it comes in terms of division, so when it's division, in order to solve this, we'll change this division into multiplication and write the reciprocal of this number. Now whether we can see anything, we can calculate, or we can do any cancellation into simplest form. Is it anything possible? No. So just directly multiply. So it is 80 by 77. So sign is there, I write the sign. So it is also a rational number. Okay. So this by this is also a rational number. Okay. These are the properties which comes the commutativity. Okay. For commutativity, what's the commutativity property? The sum of two rational numbers in any order gives us the same result. Okay. For example, again we'll take A by B, C by D. Alright, these are two rational numbers. Okay, when you take these two rational numbers, the sum of these two rational numbers in any order should get the same result. That is A by B plus C by D should be equals to C by D plus A by B. Okay, when you are adding in any order, the result has to be the same. Right. Now, for example, we take some 5 by 7, minus 8 by 3. Okay, these two are rational numbers. Okay, we'll check whether we add in this way and in this way gives us the same result. Alright, okay. Now, 5 by 7 plus minus 8 by 3. So, okay, first I am taking the same combination, which implies So here if I take the LCM, it is 21. Okay, 7 3s are 21, so it is 5 into 3 less minus 8 into 7. Alright, so 5 3s are 15 less 7 8s are 56. Because we have minus sign, I am keeping minus 56 by 21. Okay, now here plus sign is there and minus sign. We have learned in integers rise plus into minus is minus, so I have to do the operation of subtraction. Okay, so it is minus 56 by 21. Now it is 15 plus into minus is minus 56 by 21. So which implies we get minus 41 by 21. So this is the answer which we got when we subtracted like this way. Now when we subtract in the other way, okay, this is the first way, this is the second way. How we have to subtract now? Minus 8 by 3 plus 5 by 7. Okay, again here you have the LCM of 21. Okay, so here again 8 into 7 plus 5 into 3. So again you will get here minus 56 plus 15 by 21, which is nothing but minus 41 by 21. So you got the same answer here and here. So in terms of commutativity, in terms of addition, it is true. Okay, commutativity in terms of addition is true. Now the same thing in terms of subtraction. When you do the subtraction, when you solve it, it is not true. Okay, the commutativity in terms of subtraction is not true. Okay, and it is true for multiplication, it is not true for division, because when you solve like this way, alright, you will be getting a different values. Okay, so it is only because when it comes in terms of subtraction, the answer changes. Okay, when it comes in division, the answer changes. So this commutativity in terms of addition and multiplication is only true, not in case of subtraction and division. Alright, next comes associativity. Third property is associativity. Okay, what does associativity says? In terms of associativity also, here we'll be taking 3 rational numbers. Okay, how many rational numbers will be taking? 3 rational numbers. Okay, so here we'll consider some 3, we'll take example of 3 rational numbers, that is A by B, C by D and E by F. Okay, associativity in terms of 3 rational numbers. When you take 3 rational numbers, what does the associativity say is that in this property, if we group these 3 or more than 3 rational numbers in any order, the answer should be the same. Okay, whether it might be addition, subtraction, multiplication or division, here the matters is the grouping. Okay, in any order if you have to group, the answer should be the same. Grouping means first I'll group these 2, then I'll group these 2. In that way, if I check, the answer should get the same. How it is? A by B in plus C by D plus E by I. Okay, if I group first these 2 and you will get some answer. Okay, one more grouping is A by B plus C by D plus E by F. Now I am grouping these 2 and I will be solving. You will get us some answer. This and this answer should be the same. Okay, and in terms of addition, it is same. Okay, but it's not in the same of subtraction, and it is same in terms of multiplication, but not in case of division. Here also it's the same. Okay, this associativity works fine under addition and multiplication, but not in terms of subtraction and division. Alright, next comes distributivity. Fourth one is distributivity. In distributivity we have, in distributivity is on multiplication over addition as well as the subtraction. We all know it, right? In distributivity we will be using addition as well as the subtraction with multiplication. Okay, so fourth one Distributivity. So distributivity is very important, wherein we'll be using most of our exercises to solve the problems. Okay. Suppose here also I'm taking the three rational numbers. What are they? A by B, B by C, sorry, A by B, C by D, E by F. Here also I'm taking any three rational numbers. Okay. When you take any three rational numbers, okay, when you solve A by B into C by D plus E by F is equals to A by B into C by D plus A by B into E by F. Okay. This is in the same way like which we have learned in the lower classes. A into B plus C is equals to A into B plus A into C. The same formula, but it is in terms of the what? In terms of the rational numbers. Okay. So what I am doing? I am multiplying here. Okay. A, I am multiplying with this number, this rational number with this first, then I will get this, and this plus sign I am adding over here, then again I am multiplying this with this. That's it. Okay, first I am multiplying the first rational number with the second rational number, add the sign over here, and the second rational number, and I am multiplying with the second rational number. The same case in terms of the subtraction also, but here in terms of addition, I will be changing to subtraction. Here also in terms of addition, I will be changing into subtraction. So what here in distributivity we have to do is, we have to check the equation, or they will be giving us the three rational numbers. We have to check whether they are distributive. They accept the distributivity law. Okay, what it is, when you solve this equation, okay, when you solve in this way, the answer what you will get, and when you solve in here, the answer what you will get, the both answers should be the same. Okay, we'll be solving the distributivity in our exercises, coming exercises. Alright, so this is about the distributivity. Alright, next comes the additive identity, fifth one. Next comes additive identity. What does additive identity says? You take any rational numbers, any number. Okay, if you add to this number, the answer should be the number again. So what we'll be adding over here? We'll be adding what? What we'll be adding over here to get the same number? Take a number. Okay, add to be added some number so that we get the same number. So we'll be adding what? We'll be adding 0. Yes, when you add 0, so any number if it's added with 0, you'll get A by with the same number. So here the additive identity is what? 0 is called the additive identity. Next one, multiplicative identity. Multiplicative identity. What does the multiplicative identity says that? Okay, take any rational number. Okay, if you multiply with any rational number, you should get the same number. So what will multiply? Yes, we'll multiply with number 1. So here multiplicative identity is number 1. Okay, I'm thinking let me take some examples for additive identity. Okay, here if you take one example, okay, 4 by 11. If you add some number, you should get 4 by 11. So what it is? 0. So for this additive identity, we will be solving like this. Okay, any number, if you add with 0, you will get the same result. So 0 is called the additive identity, and when you multiply 1, you will get the same answer. So here 1 is called the multiplicative identity. Alright, next comes the additive inverse. Alright. Additive inverse. What is additive inverse? Okay, when there is one rational number, if you add to that other rational number, you get answer as 0. Suppose if I take one rational number of, I'll take one rational number as a by b. So what will be the additive inverse of a by b? Minus a by b. Wherein we get answer 0 when you add together. Suppose if I take minus a by b plus, or else I take one example. Alright. For example, if I take 2 by 3. Okay. What's the additive inverse of 2 by 3? It is minus 2 by 3. Alright. Now if I take minus 4 by 10. What is the additive inverse of minus 4 by 10? It is 4 by 10. Okay, that's about the additive inverse. Next comes the reciprocal. Reciprocal. Okay, now you take any number. The reciprocal of this number, you should get answer as 1. So what you do into b by a. Just reverse the numbers. So reciprocal of 3 by 11 is 11 by 3. Just inverse. Okay. Okay. So these are some of the properties of the rational numbers. Okay. Next sessions will start with the exercise 1 from the chapter rational numbers. Alright. Thank you.